As promised, I have a solution for week 2 handout. Question number 1. When I say this question number 3, this is question number 3 from your textbook here. An automobile travels on a straight road for 40 kilometers at 30 kilometers per hour. It then continues in the same direction for another 40 kilometers at 60 kilometers per hour. What is the average velocity of the car during the full trip? From here, come on. V average, which is change in displacement over time. Displacement, we know that is 80 kilometers divided by, we have two times, okay? For the first 40 kilometer, T1, T2, let's find T1. T1 is 40 kilometer divided by 30 kilometers per hour, okay? So if we use that, we get 1.33 hours. T2 oh sorry, 60 kilometers, not 0.66 hours. All right, so V average is, this gives us 2 hour, so 80 divided by 2 kilometer hour is 40 kilometer per hour. What is the average speed? So this is just traveling in one direction, so we don't have to do anything else. So 40, we know it's going in one particular direction, so that's going to be the speed. So speed S is going to be 40 kilometer per hour. Yeah. Similarly, in part C, draw a graph. So to draw a graph, what you can do is this is my X, so 0.5, sorry, this is time in hour, 1.5, 2, so we have to go up to 80, so we have to I don't have calibrated fingers, so I will try to be 10, 20, 30, 40, 50, 60, 70, 80, and 90. So 1.33, it travels, why does it do this? 1.33, come on. 1.33 would be somewhere, come on, this. All right, so 40 would be about here. And then 2 hours, it's at 80, so your graph would look something like this. Okay. Not exponential, sorry. This one looks, all right, question number 2. The position of an object moving along x-axis is given by x equals to 3t minus 4t squared plus t cubed. Find the position. So to find the position, x at time equals to 1. The function of x is with respect to time. So x1, 3 times 1 minus 4 times 1 squared plus t1 cubed. That'll give 0 meter. Similarly, you can do for 2. x2 is 3 times 2 minus 4 times 2 squared plus 2 cubed, that is 6 minus 16 minus, sorry, plus 8 meters, that is negative 2 meters. That's the position. Now you can do the same thing for 3, that is x3, 3 times 3 minus 4 times 3 squared plus 3 times cubed. That should give you 0 meters. Similarly, x at 4, 3, 4 minus 4, 4 squared plus 4 cubed. That should give you 12 meters. Now, you are to find the average velocity. So when I say average velocity here, you are trying to find the average between time equals to 2 and 2. So V average is x4 minus x2 divided by t4 minus t2. We know that t4 minus t2 is 2 seconds, 4 minus 2. X at 4 is 12 meters, minus x at 2 is minus 2 meters. So you have to be careful with that. So that gives you 14 divided by 2, that is 7 meters per second. Now you are to graph it. So it's a rough graph. Okay. So t seconds, x in meters. Okay. 1, 2, 3, 4. Your graph should, at 2 it was negative. Okay. We just go back at x equals to 1, it was 0. X equals to 2 was negative 2. X equals to 3 was 0. Okay, so your graph should look something like that. All right, if the position of a particle is given by 20t minus 5t cubed, where x is in meters and t is in seconds, when, if ever, is the particle's velocity 0? Okay, first thing, you find the velocity is dx over dt. Take the derivative, so that gives you 20 minus 15t squared. So when is the particle velocity 0? So you set that velocity to be 0. 20 minus 15t squared. Okay, so t is square root of 20 divided by 15, which is 1.2 seconds. When is the acceleration 0? So for us to do that, so we have to find acceleration first. So acceleration is dv dt, that is negative 30t. So acceleration is 0 at t equals to 0 seconds. For what time range is acceleration a negative? So we know acceleration's equation is negative 30t when t is positive. When t is greater than 0, acceleration is negative. So t less than 0, acceleration is positive. So similarly, you can draw a graph. Okay. Just for the visualization purpose, you can plug that into your scientific calculator. This is your VT. Acceleration is constant. Sorry, this is not constant, negative 30t. So a. Okay, this one, I have solved this properly in class, so I'm not going to go in depth. So suppose a rocket ship in deep space moves with constant acceleration equal to 9.8 meters per second squared, which gives the illusion of normal gravity during the flight. If it starts from rest, how long will it take to acquire a speed 1/10 that of light, which travels at 3.0 times 10 to the power 8 meters per second? Starts from rest, v initial 0 meters per second. Final speed 1/10 the speed of light. So which is 3 times 10 to the power 7 meters per second. That's given to us. Now acceleration is 9.8 meters per second squared. So v initial plus at. So we find time, v minus v initial divided by a. Six seconds, which is approximately 1.2 months. Okay. How far will it travel? Okay. So x, we have this equation, x equals to x initial plus v initial t plus 1/2 at squared. So x equals to, so this x initial is 0, v initial t is 0, v initial is 0, so 1/2 9.8 meters per second squared times 3.1 times 10 to the power 6 seconds squared, which gives you approximately 4.6 times 10 to the power 13 meters. All right, raindrop fall 1700 meters from a cloud to the ground. If they were not slowed down by air resistance, how fast would the drops be moving when they struck the ground? Okay, let's see. So in this case, we consider down to be positive. So v initial is 0 meters per second. Acceleration 9.8 meters per second. Since we are talking in a y direction, so I'm gonna instead of writing in terms of x, I'm gonna write everything in terms of y. We know our y final minus y initial. So that is positive in this case, which is change in y. That is positive because we chose down to be positive. That is 1700 meters. So we use this equation, v squared equals to v initial squared plus 2a change in y. V initial is 0, so the final velocity is square root of 2a change in y. Plug in the numbers, you should get v to be 183 meters per second. That's a very high speed. You don't want to be in that kind of rain. Okay, no air resistance, so air resistance take care of the speed of the raindrop, so it does not fall at very high speed, as 183 is pretty much close to a bullet speed. A ball is shot vertically from upward from the space of another planet. A plot y versus t is shown, where y is the height. So y is the height of the ball above its starting point, and t equals to 0 at instant the ball is shot. The figure's vertical scaling is set by ys equals to 30 meters. What are the magnitudes? So just by looking at the pictures, like here, time positive, y positive, so it takes about 2.5 seconds to reach the max height. This is the max height. You can use you can solve this problem two different ways. Okay, one, either you can just choose like going up or coming down. Okay, whichever you pick. Okay, I'll solve both ways. Let's see if I have space here. Going up. Okay, let's write the variables here. Going up, coming down. So while going up, v initial, we don't know that. Okay, it was shot at some speed. V final, at the top of the projectile, at top of the motion, v is 0. Acceleration, we don't know that, right? T, to reach the max height, we are just going, I'm just considering from starting point to the time it takes to go to the max height. So that is 2.5 seconds. Y initial, 0 meters. Y final is, this should give you 25 meters here. Now, we are using this equation, y minus y initial equals to v final t minus 1/2 at squared. Okay, so y initial is 0. If we, y final at the top is 0, v final, sorry, so 25 equals to negative 1/2 a 2.5 squared. Acceleration is negative 8 meters per second squared. All right, so acceleration comes out to be negative, right? So coming down, so v initial, so we consider this as a separate problem now. At the top, v initial is 0. So we can consider either going upwards or coming down. So while coming down, now our positive axis is up, so y initial, so we consider that to be the y initial point, because we are changing our reference, like the origin. Okay, so y final is 0. Acceleration is what? Because this is the final height. So t 2.5 seconds. So y equals to y initial plus v initial t plus 1/2 at squared. Y final is 0. Y initial 25. V initial at that height is 0, so this becomes 0 here. 1/2 a 2.5 squared. So acceleration is -8 meters per second squared. Doesn't matter how we do it, we still got our acceleration to be -8 meters per second, because which initially, like if you're looking at the graph here, our axis is pointing up. We have chosen up to be positive. Okay, so now doesn't matter how you do it, we can find the second part is to find the initial velocity of the ball. So v equals to v initial plus at. So we are supposed to find v initial. So if you pick going up part, v final at the top is 0, right? So v initial is -at. So negative acceleration was negative, so -8 meters per second squared, okay, times t. Because look, like, so our velocity initial has to be positive, because our initial velocity was up and we chose up to be positive. Okay, so 20 meters per second. There you go.